Okay, good afternoon, everybody. We are going to start with the keynote lecture number 4. Let me say some words about our presenter, which is Professor Tim Kehoe. Tim Kehoe is a renowned American economist. He received his PhD in economics from Yale University and has held teaching positions at Wesleyan University, the MIT, and the University of Cambridge in the United Kingdom. Tim has been a professor in the Department of Economics at the University of Minnesota since 1987, where he is currently a distinguished McKnight University professor. In addition, he is an advisor to the Minneapolis Fed. His research and teaching center on the theory and application of general equilibrium models, especially in macroeconomics and international trade. Tim advised the Spanish government on the impact of joining the European Community in 1986 and the Mexican government on the impact of joining the North American Free Trade Area in 1994. He designed also foreign trade and investment reform program for Panama, which was enacted in 1998. Tim has held visiting professorships at many universities, including CENFI, the University of Alicante, the University of Barcelona, UCLA, the Universidad Carlos III de Madrid, the ITAM, University of Maryland, and Colegio de Mexico, among others. He has written over 100 books and scholarly articles, including The Great Depressions of the 20th Century, edited jointly with Ed Prescott. He serves on the boards of numerous educational and research institutions and professional journals. But above all, he's a very good friend who enjoys grabbing a beer after a day of hard work. Welcome to Tim Kehoe.
Thank you very much, Carlos, and I'm looking forward to the first beer. So I'm not going to keep us too long. I've actually changed the title of the presentation, but it's something on a similar project, and I hope it's. I found the other paper exciting too, and when we're having a beer, I could discuss that. This is related. It's something that's joint work with Jose Asturias, who's in Georgetown University in Qatar, Sean Herr, and Kim Rule. And in it, we ask a question. We'll see if the results are surprising. This is kind of a case of macroeconomists looking at a question in applied micro and seeing what we learn. We're asking, where does productivity come from? And when we looked at the literature, we saw a couple answers. Now, here are two papers that are very widely cited, especially the first one, as we'll see, by Foster, Halterwanger, and Kreisen. Is important not only for motivating a lot of work in macro, but also it set the benchmark for how to do some of the decompositions of industrial census data that we're going to look at. They come up with an answer looking at 3 different 5-year windows in the United States that net entry. Now, I'm going to be very precise about that, but I'm not going to want to spend that much time looking at the details of the formulas. Recently, there's been some work that criticized this way of doing decomposition, and that's not the ballgame we're in. We're going to use this decomposition in the data, and we've managed to obtain 2 very interesting micro data sets that I'm going to talk about in a little bit of detail, and we do the same in the model. So if this gives us a biased estimate, as Mark Mellitz in some of his recent work tries to push, that's all the same to us. It's the message in the data and the model, it's how they match is what concerns us. So they come up with a number and says that net entry, new firms entering, old firms dropping out, accounts for about 25% of US productivity growth. Now here's another paper by Brandt van Wiesenbroek and Zhang that says 72% of Chinese productivity growth comes from net entry. They're actually for different windows, and I'm going to talk about that. You need to have exactly the same windows of time to do comparisons, but the macro papers I've seen don't even think that carefully about that. We will do that. You look at those papers, and you'll find they get lots of citations in the macro literature. They're very widely cited, and people conclude the opposite. they often call net entry creative destruction. So if you look at papers that are all applied and have creative destruction in the title, you'll find them often referring to one of these two papers. And if you cite the first one, you make the point creative destruction is unimportant. And if you cite the second one, you usually say it's everything. Okay, so we have a puzzle. Now, there are some resolutions in the puzzle, and unfortunately even a couple of students of mine did this because I was very confused about this for a while. And I thought it was a advanced country, less advanced country phenomenon. That in advanced countries, net entry, creative destruction, as it's often called, is unimportant because there's less problems of firms adapting as they're existing new technologies. And in third world countries, it's everything. You have to have the old firms die and new firms be born. Well, we're going to give you a very different answer. We're going to find it's a regularity in all the data we've been able to find. And as I say, we'll do our own micro econometric analysis of two different micro data sets. During periods of rapid GDP growth, rapid productivity growth, it's going to be net entry. During those periods, most growth is going to show up as new firms entering, old firms dying. And they go together in general equilibrium. And during periods of slow growth, but I'll call normal growth, about 2% per capita, like the United States, it's going to be relatively unimportant. So it's creative destruction, if we want to call it, is important if a country's going to grow a lot. If a country's just growing by a slower amount in what we're going to model as a balanced growth path, it's not going to be important. Now, we managed to obtain plant level data from Chile and Korea, and it goes back long enough that we have a fast growth period for each and a slow growth period for each. We're going to also look at all the literature that uses the same decomposition that we do, the one due to Forster, Halterwanger, and Krizan. We're going to adjust the windows so that they're all the same, or at least do an estimate of that. And we're going to find that during periods of fast growth, 52% of productivity growth comes from new firms entering, old firms dropping out. And during periods of slower growth, it's 27%. Now, let me give you a more nuanced view of this. You'd be tempted to think from looking at this, and this is something the World Bank pushes sometimes, to grow rapidly, you need to make entry and exit easier. You'd be tempted to have that policy conclusion. And I just don't think that's right. Net entry and exit is important during a period of rapid growth, but if you do something else besides lower entry barriers that enhances growth, you get an effect that looks almost exactly like you lowered entry barriers. Entry and exit's going to happen if you do something to speed the economy up. It's almost inevitable. I mean, I go all over the place, and when I give popular talks, I try to tell people, look at the World Bank's Doing Business report, which is all about the barriers to entry and exit. If you improve on that, you can improve a country's productivity growth. But if you do other things to improve technology adoption from abroad, you're also going to get results that look as though you've improved on entry barriers. So it's kind of nuanced. We're going to construct a model of firm entry and exit, calibrate it to the United States. We're going to lower entry costs, and then we're going to also lower other kind of reduced form barriers to growth that looks like, say, Parente Prescott barriers to riches. Just something that affects the rate at which you can adopt technology abroad. And we're going to see in both cases, rapid growth is going to result in situations where when you do the decompositions, most of the growth is happening because of entry and exit. So data. We're going to talk about the Forster-Halterwanger-Krizan decomposition, and then we're going to take our two data sets that we were able to get our hands on and look at periods of rapid growth in both Chile and Korea and periods of slower growth in both Chile and Korea. Then we're going to look at everything we were able to find in the literature. If any of you guys have access to other studies, and we're going to try to branch out, but right now we're trying to stick with studies that use Forster-Halterwanger-Krizan. Of course, if anyone could give us more micro data sets, we'll do it ourselves. Took a while to get our hands on these two. Although now the Chilean data is public. It wasn't when we started working on this. So let me go through this, and the details of this are not important since this is something that shows up in Forster-Halterwanger-Krizan. But what we're going to do is we're going to look at industries. And I'll tell you in each data set what an industry is, but think 40, 50 industry, all manufacturing data. So there's a limitation here. And what we're going to do is in each industry, we're going to look at productivity growth as a geometric average of the growth of the firms that are in the industry with the shares, or we're going to stick with gross output shares. Our results are kind of robust to using labor shares, which is also common in the literature. And TFP is going to be the total factor productivity of a plant. A little bit of vocabulary here. I'm going to be schizophrenic. I do lots of economic theory, and we always call these guys firms. We're going to look at the data. We get our industrial census stuff. It's always a plant. Look, I know there's lots of multi-plant firms. If we had really great data, I'd try to take that into account. There might be economies of scale and sharing some fixed costs across plants in the same firm. We don't have any of that. How that would change the results, I don't know. Then we're going to look at the changes over a window. And I'm going to normalize all our windows to be 5 years. I'm going to tell you how we're going to do it. Problem is, as you increase the window, you would expect the fraction of growth due to entry and exit to increase. So I got to normalize the window. We'll stick with 5 years, which was the Forster-Halterwanger-Krizan number. And then, and this is why we focus on industries, I'm going to estimate industry production functions. And what's that going to do? Well, I'm going to keep the cost shares in each country, in each industry constant. And I'm also going to use price deflators for the inputs and outputs that are kind of industry constant, not over time, but all the firms in the industry have the same deflators. This is going to be a perfect competition model. So I saw Ugo Hoppenheim running around before, and too bad I didn't tell him to come, but this is a Hoppenheim model. It's not a Mellitz model. Mellitz model, where you take Hoppenheim and stick in monopolistic competition, is much more problematic because there's price setting going on there. We don't have that. Woolridge, Levinson, Petrin, we kind of stuck together 2 papers there. They have more sophisticated ways of doing productivity. Our data for Chile allowed us to do that, and we got about the same answers. Okay, so here's what we're going to do. We're going to come up with something that says the change in industry productivity that we see over 5 years, how much of it is due to net entry and exit of firms, and how much is due to continuing firms. When you actually look at the existing Forster, Hauptwanger, Krizan paper, you're going to find there's 5 terms, and they just arrange them in different ways. You know what's kind of discouraging about this? You write to some of the authors and you say, well, how did you get those numbers? And can you actually give us maybe access to the data, or just show us how you did the 5 terms and aggregated them up into these 2? And then I feel guilty because I'm reminded of people sending me emails and something like that, and sometimes I say, you know, I don't have a clue how I did that. You know, we published that paper 12 years ago. I'm not sure I can find the computer programs anymore. Yeah. I mean, that's a lesson for you. So I don't know what to say. But, I mean, I think that's a problem that's endemic here. And I bet except for you young guys, but the older guys, you all know what I'm talking about. Somebody asks you details of a paper you wrote 15 years ago. It's hard to come up with it. And so I've been on both ends of that. But that means especially people who have access to census level data, and they report things, those things become like part of the shared wisdom, and yet who has a clue exactly what they were doing, or if there were mistakes? You know, I don't know. All right, because you'll see this in some of our, I'm not going to spend much time saying where I think some studies might have made mistakes or not. But here I'm going to show 2 of the terms. I'm just going to take the productivity that we're going to get by having new firms entering, that's the first line, that's the small z, that are more efficient than the average firm in the industry the previous, not previous period, beginning of the window. So there's 5 years going on here. Think 5 years. And you're going to have firms drop out, weighted by the shares they had at the very beginning, that we're looking at the difference between their productivity and the average at the beginning of the window. And then there's more complicated terms that involve within firm growth and reallocation across firms because of changes in shares over time. We're going to stick that all together. As I say, we're going to estimate from industry, from firms up to industries, and then we're going to estimate from or aggregate from industries up to aggregate by using shares of growth output by industry. So let's look at Chile and Korea. Here's the history, economic histories of Chile and Korea since 1985. And what we see, of course, and everybody knew this, between 1985 and about 1998, Chile and Korea were two of the fastest growing countries in the world. And we have these 5-year windows. Korea grew by a little bit more, but the particular 5-year window we focused on, 1992, 97 in Korea, they grew a little bit slower between Chile did in 1990 to 95, where they grew at 6.8%. Then they both had little bits of crisis. We didn't want any of those recession episodes in our data. One, of course, in Korea was more severe. Chile then has slow growth around 2.4% per year between 2001 and 2006. And we're going to call 4% per capita in Korea slow between 2002 to 2007. Just, it's slower. Carlos Gustavo mentioned the stuff I've done with Ed Prescott on Great Depressions. And so you've probably seen the kind of overall, well, those of you who have been fortunate enough to see it, have seen the kind of overarching theory we have. The United States has grown at 2% per year per capita since 1875, except for the Great Depression and the boom afterwards. And we say every country should grow at 2% per year just by adopting best practice technology in the United States, or wherever the leader happens to be. We use the United States for short. If we're thinking automobile industry, for many years it was Japan, and so forth. Okay, you have a rapid growth period, you're doing something well, and you have a transition path. Then you get to wherever you should be just because your institutions and policy. Chile's kind of there. Chile has to do more reforms. I see my friend Raimundo right up front, who wrote our paper in the Great Depressions book on Chile and Mexico with me. But you know, Chile's going to have to do something if it's going to pick up. China is slowing down now. I think China's hit the wall. That's another topic to talk about over beers in a bit. Korea hasn't hit the wall soon, but they're conscious of being caught in what they now call the middle income trap. But that's just the same kind of slowdown, Raimundo, that we were talking about 15 years ago. So, we got the data from Chile, the Encuesta Nacional Industrial Anual. It has 127 industries, 5,000 plants, and we have our 2 5-year, 5-year? We had 2 panels. Yeah, there's an incompatibility across the panels, and we took our 5-year windows out of that. From Korea, we got their survey of mining and manufacturing. Now, both of these are, you're going to say, encuesta in Spanish, of course, means survey. They're both survey. No, but they're exhaustive surveys. Any firm that has more than 10 workers is included. So it's census level. The problem is less than 10 firms. It's a problem endemic in this kind of literature. Other people have looked at that and tried to make the case that this doesn't bias the results, that this is an our battle. Okay, so here's, if you just wanted to see the kind of fact from the data and skip the model, then you could leave. But we got to wait for the bus anyway, so I'm going to try to show you the model too. So what happened in Chile during the period of fast growth, we see that 85% of that was net entry. And then during the period of slow growth, it dropped down to 35. In Korea, of course, the drop in aggregate growth wasn't so big, and the drop in the effective entry wasn't so, net entry wasn't so big, but it's still there. Goes down from 48 to 40. Now, I'll talk about this later because we've had questions about this before. Where is this coming from? It's primarily coming from, just as it will in our model, from the entering firms, that first subterm, not the exit. The exit usually contributes, but that's more or less constant. It's the entry terms that are so important. Okay. When we look at the decomposition, there is something interesting here. And I can see we're going to have to do something with the model. It's going to be that the entry rates pick up a lot during the fast growth period. That's the first column. What are those numbers like 20.8? Well, 20.8 is the number that gives us 85% of the aggregate productivity growth. So when we break that down into the different components, it's both the entry rate and the relative productivity of new firms pick up. The relative size of entrants doesn't pick up. You see, in Korea, the new entrants are about half the size of existing firms. Those are the last two numbers in the far right column. Where in Chile, it's fixed at right around the same size. And we're going to have a number that's going to give us the Chile thing, not the Korea results. I kind of know the model, but I'm trying to look for evidence to justify that. If we had variable capital, and we're going to have capital all being fixed costs, so that firms enter at the optimal size. But if we had firms really constrained in what they could do in investment, borrowing constraints, so firms would have to enter at suboptimal size, we could get the Korea numbers. But what stands out here is how the two countries are so different. We're going to have to go back and study that. See, if I was at the University of Minnesota with my grad students, I'd say, wow, you could write a thesis on this. And maybe one of you guys can even beat us too, figuring that out. I don't know what's going on, why in Korea firms enter at suboptimal size and in Chile they don't. So, we looked around and see who had numbers that used the same kind of decomposition we did, and we also divided them up by how much the countries were growing. As I mentioned, different studies use different windows, and it makes comparisons difficult. So we're going to do the crudest thing you can imagine. We're going to take our model, which I haven't described yet. We're going to come up with results for 5-year windows, 10-year windows, 15-year windows. Then we're going to fit a quadratic through the points, and we're going to adjust all the other data proportionally. Let me give you an example. So in our model, if we have a 5-year window, we'll already see that 25% of growth is due to new entry. Whereas with the 10-year window, it's 40%. Those are those black dots. We find somebody who had a 3-year window. We're just going to find the point on our curve and adjust proportionally. I wish I knew a better way to do it. But this was for Portugal, had a 3-year window. They found 15% of growth was net entry. We're going to see that, 5-year window 25%, 3-year window 18%, proportional adjustment. We're going to claim that those researchers found that 21% of growth, not 15, was due to net entry, because we're going to scale it up. Oof. Bet my friend Lars Hansen sitting over there saying, you shouldn't give these theorists all these numbers to play with, you know? I mean, I look for a better way to do this, but this is what we did. We have to make adjustments to get the windows comparable, and we don't have their data. And in most cases, it's confidential data they're using. We got to do something crude. Here are the numbers. You see in the right-hand column, all the kind of balanced growth path, 2%. They're not all 2%, but the average is about 2.6% episodes, and we're getting about 27% on average of growth in those countries due to net entry. In the faster growing countries, you see the average growth 6.3% per capita and 52% student net entry. Then you'll also see that in Chile, I don't want to get in trouble here, Raimundo, but you see our friends Rafael and Andrea, they did it, and they got a lot different numbers than us, and we don't know where they're coming from. But then I graph the numbers, we run a regression line through it. Kind of looks good, huh? The more you grow, the higher percentage of growth is going to come from net entry. And we almost think this is a regularity. And I'm going to convince you that the same kind of numbers can come from wildly different reforms. One a set of reforms directly on entry costs, and another a set on reforms that just do Parente Prescott to demolish barriers to riches. So here's the model. How am I doing, Carlos Gustavo? Oh, poof. Well, I got to show you the model. You can guess how this is going to work. We're going to have U.S. productivity growing 2% per year since 1875. I don't know what, anyone who looks at my webpage, you know, years ago I had a picture of me and my wife there. And then I put up a graph of U.S. economic history since 1875. I think she was relieved. She said, why do you always have that old picture of us? But then she said, what is that new picture? I said, oh, that's what I'm trying to figure out. Why does the U.S. grow by 2% all the time? I don't know. Robert Lucas is trying to figure that out. But I mean, you need kind of higher level than me to figure that out. I'm going to take it as given. And if we're here in Bolivia, or if I go to Mexico, we're going to take that as given. We better be growing by at least 2%. And as you know, we haven't been. So we're screwing something up. But it would be even better if we could do reforms to grow by more than 2%. Then continuing firms are going to grow by less than 2%. So we're somehow hardwiring some of the results in, but we're going to come up with estimates of exactly how that GC moves. This model is also going to have a very tractable balanced growth path. You'll see in a minute. The balanced growth path, only GE is going to determine that. And as I say, that's going to be, if we use annual data, it's 1.02. The factor by which best practice, as management consultants would call it, don't be trapped thinking this is what the engineers and scientists give us. Of course, that's a little bit of it, but it's what the management consultants tell us is best practice. Read this book by William Lewis, called Power of Productivity. He was a management consultant, and he'll tell you what productivity is. A little bit is science and engineering. Douglas North found improving transatlantic shipping, the biggest thing that did that was eliminating pirates, not any technological thing. Eliminate pirates. Maybe we should think about that in Bolivia and Mexico. Consumers are uninteresting. We're going to have a model of firm dynamics that's going to be Ugo's model. Heterogeneous product efficiencies. Some of the versions of the model, we just use Pareto because it's nice, but we need to put things on the computer anyway to do the transitions, and we get the same results with log normal. Crucial things are you have to pay kappa to take a drawer of productivities and a fixed cost afterwards of F to operate. And some firms are dying anyway. If you want, that's the stochastic productivity factor. Some firms find their productivity drops to 0. We could put in more interest in stochastic productivity. It doesn't do anything. So we're leaving it out here. Here's our view of the world. It's kind of a bit crazy, but it's common in this kind of literature. We're going to calibrate a technological kappa, cost of trying to come up with a new firm, by looking at US data. And we're going to say US is undistorted. Now that's probably not right, but we'd kind of say, well, the US, since it's at the top of the doing business surveys, it's not Singapore is, but you know what I mean, it's towards the top. And other countries can be screwed up because the government gets involved, makes it tougher to start businesses. Go to a country like Spain, you can see it. I mean, sometimes Spain surprises me by how rich they are, given how tough it is to start a business. And those of us interested in Latin America, remember a lot of this came from some of the early work that, and the impetus for doing business came from Hernando de Soto's work, where he does the experiment, takes the woman from the countryside in Peru, asks her to set up a business legally, not pay a bribe unless she couldn't keep it going. Took her 180 days and 2 bribes. He did the same thing with a Puerto Rican woman in the Bronx in New York. It took her an afternoon, no bribes. So that's that tau. And we're going to talk about reducing that. And then they also have a fixed cost of operating. Both of them increase over time just to keep at the same rate that the whole economy grows. Or if it was in the balanced growth path, just to give us balanced growth paths. Firms only have 2 interesting decisions: enter or exit, and maximize profits. This model's simple because if you do enter, you enter at the best size. Like I say, I want to experiment with that, or maybe some of you could. But the entry costs distort decisions a lot. It really stops firms from experimenting. And that kills a country. You want to have as many firms trying to enter as possible. You want fierce competition. That's what makes a country grow. Yeah, my Spanish friends say, you know, when we were studying this stuff, we always learned the best industrial policies were the ones that promoted really big firms and pumped all kinds of resources in the existing firms. I said, that's the worst policy I can imagine. Like I say, sometimes Spain, and I see in the audience friends of mine I've seen in Spain, and you know what I'm talking about. Country, yeah, they're doing surprisingly good. I know they're doing very badly, but it's surprisingly good compared to how bad economic policies they follow. So, okay, more efficient firms are bigger. That's standard. We solve dynamic programming problems where we're looking ahead, thinking about how long we're going to live, with our efficiency growing at GC. GC is going to involve both a constant rate of growth that you get in any environment, plus some kind of spillovers from the aggregate growth. You're learning by having more new guys enter too. And we're going to look at the data to estimate that. Simplest model, just Pareto. Things are shifting out by the factor GE every period. And we're thinking about barriers of technology adoption, which is the fee term. And then there's all kinds of interesting data keeping we got to do. We got to keep track of all the firms that have entered in the past, that haven't dropped out, and so forth. Definition of equilibrium. Can't get through Minnesota unless you can do this, but I'll just skip it over. And then we get these balanced growth paths. And the balanced growth paths, given our Pareto distribution on productivities, is pretty easy to characterize. And we're going to see everything moves out, including the crucial decision when to operate and when not after you take your draw. That's that X hat T. Everything just keeps shifting out by the factor GE over time. Comparative statics. If we lower kappa, we're going to have more guys take draws. You say to young guys, do you want to be an entrepreneur, make a lot of money? We're going to make it easy for you to try to set up a firm. But guess what? We're going to make it easy for everybody. Try. It's no disgrace if you fail, right? Then you just become a worker. And that's what happens in this model. So we lower the cost of entry, more guys try to enter, the cutoff for efficient firms goes up, wages output increase. Barriers to adoption ends up doing similar things. Let's look at the numbers. We calibrate to the US. I'll assume that you believe that I know how to do something like that. So we do it. Here's what we also do, because when we compute TFP, we have to say what a firm's capital is and its depreciation. And we just said it's all the fixed costs you pay. That's the factory, the equipment you got to install. Okay? So that's what this is about. We're going to have our model matches size distribution of plants in the United States, the effect of continuing firms on productivity growth, and employment shares of existing plants. And we get that. We do regressions to get our technological spillover of firms. We're cheating. We're using Chile, Korea data to do it, and we should do US data to be consistent. We don't have access to the Bureau of the Census data. Maybe we got to get someone to do it for us or get access. So here's like the picture. Maybe this is like Japan in the 1980s. It does something right. It starts growing fast, looks like it's going to pass the US, but of course it's not. It's going to level out once it gets to its correct level. And that could take you about 15 years, that transition. But during that time, of course, you're going to have fast growth. Here we lower entry costs, and we're going to get a large amount of growth. In fact, we've calibrated how much we lower the entry costs, so we grow by 15%. And you see here, the massive potential entrants is what's driving this. But we get our thresholds increasing 15%, massive entering firms increasing, I'm sorry, that's only by about 8%. Exit also increases. Wages, output are going up by about 25%. Now, during that period of fast growth, 75% is becoming from net entry. We start at 25, we're going to 25. It's constructed that way. We reduce phi, except for the fact that the massive potential entry doesn't pick up. All the pictures look the same. We constructed the absolute increase in GDP to be the same. And again, 75% is due to new entry. Okay, now my theory side is coming out again. And I look at those numbers, look at the two data columns, where this is from what we saw at the beginning. In countries that grew at around 6.3% in adjusted 5-year windows, 54% of growth was new entry exit. In our model, no matter which of the first two reforms we do, we get about 5.5% growth, and 75% is due to net entry. If I was an econometrician, I'd say, oof, I'm going to reject your model, but I'm a theorist, I'm going to say, that's not bad, you know? We're picking something up. And in the slow growth, well, 25 and 26%, comparing the third column and the last column, they don't look bad at all. Of course, what we called slow growth had the Korean slow growth experience in, which upped the number to about 2.6 on average, but not bad. Here I'm decomposing the numbers. Once again, it doesn't look that great, but the big difference is always the entry rate in both the data and no, it's not. Maybe we need to look at that. Calibration and experiments need a bit more work. But what did I learn here? See, and this is what I want to think about, because when I look at the literature, I see so many macro guys. We just read the microeconometric stuff that we want to read, and then we twist our models around. We read this stuff about China, and we say, you know, or Chile, you know, and we say, net entry is everything. We really have to look at models where it's creative destruction. Then other people look at US data and say, no, all growth comes from within firm growth. Well, guess what? Those are more or less accurate summaries of things out there in the literature, but the U.S. experience that Forster, Halterwanger, and Krizan were looking at was slow growth periods. If you want miracle growth, you got to look at other miracle growth cases, and you see in those cases, it was because of entry and exit. Does that mean that we need to just focus on those World Bank numbers? And I've heard people from countries that are successful saying, wow, why don't we look at improvements in the doing business ranking of our country rather than the standings of our national team in football, soccer, as indication of how well our country is doing? Right? Some of my friends from Brazil, what do you think about that? I mean, that'd be something to look at. But, you know, and I go around saying stuff like that, but it could be misleading. Because, you see, as your country grows, for some other reason, entering as a firm becomes more attractive, and the results look almost as if you would cut the entry costs. I don't know. Am I like the two-handed economist that Lyndon Johnson was always complaining about? You know, on one hand, on the other, but it is like that. Entry and exit are important, but that's not to say we have to focus our reforms on them. We have to generate any reforms that give us increased entry and exit, and they're not necessarily just going to be lowering the costs of entry and exit. Okay? Thank you very much.
Thank you very much, Tim. We have exactly 2 minutes for 2 questions. Is there any question in the room? Okay, I think.
of reforms? No, and in fact, that's truly essential. What I think we should do is for both Chile and Korea is actually go through a list of reforms that we think were important for those two countries, because that's where we have that micro data at our hands, and do it. That's a great suggestion, Aloisio.
I don't know how you interpret the situation in Spain through the lens of your model, in the sense that during the boom years, TFP was flat in Spain, and during the recession, there was a huge increase in productivity. And if you think about the data, you would think the opposite.
Right.
So I don't know if maybe Spain's an anomaly, or you think...
No. All right. No. So for Spain, and my friend Antonia Diaz in Carlos Tercero has a paper about this. You know what happened during the boom in Spain? There's all kinds of resources were going into a sector with not only flat but falling productivity, which was the construction sector. So that is a kind of, that is an exception. But you know, aggregate productivity in Spain hasn't gone up since 1995. Yeah, it was kind of flat, it went down, it's going up, hasn't boomed. But you're just saying, oh, it's shocking that it's going up at all, given the experience of the last 25 years. No, Spain, you know why lots of the growth happened? The population of Spain went from 39 million, which it had been relatively constant at since about 1970. It went to 47 million between 2002 and 2007. And how did that happen? They all of a sudden remember how to have kids? No. It was immigration, and where was it from? And we know where it's from. A lot from Latin America. Ecuador has 14 million people, 1 million of them live in Spain. Eastern Europe, shorthand they say Romania, but there's other countries there, of course, and North Africa. And those guys worked in the construction sector, and they put in long hours working. But output did not go up as much as they put in hours working. So that was an interesting kind of episode. But that was the boom in Spain. It wasn't productivity, as you know. They have to do something. I mean, productivity in Spain's been stagnant for now 20 years. And as you know, I go there all the time, and if I come up with a better answer, so maybe while we're having a beer, try to give me a suggestion, and I'll store it in my pack. Okay, muchas gracias, y creo que hay cerveza esperándonos, que nos vamos.